Hello, welcome to Maphy's YouTube channel. Today we are going for complete P3 revision. So let's start. First of all, the most important thing is that the graph sketching. Okay, so first of all, we are going for graph sketching. Take note with me, it will help you a lot as a complete revision will be done with me. So let's start. First of all, in graph sketching, first is quadratic curve. We all know about quadratic curve and it is easy. Quadratic, we can express this like this way: y equals to k x minus a whole square plus b. Here the turning point is a and b. How we considered this as x minus a is equal to 0, so x equals to a, so x coordinate of the turning point is a and y coordinate is the b, and it is in complete square form. Okay, it is in complete square form. In quadratic there are two type of curve: number one, which is like this smiley, and number two, which is maximum. It is minimum, is maximum. Here the coefficient of x square must be greater than 0, and here coefficient of x square must be less than 0. Okay, now we can go for the cubic curve. Okay, in cubic curve we can also write is in this form, like this way: y equal to k x minus a whole cube plus b. Here we say turning point, but it's actually the point of inflection. However, we call it turning point. Similarly, like this way, a and b. For example, I can give you a curve that is y equals to 2x minus 3 whole cube plus 2. For example, here the turning point is 3, 2, right? Okay, so this turning point is basically the in point of inflection. So 3, 2, here for example 3 and 2. So our curve would be like this. Okay, this point is the point of inflection, and the cutting point in y coordinate is the 2, 0 minus 3 whole cube plus 2, that is minus 52. Okay, so I think you got it. That's what is this point. This point basically called the point of inflection. Then there is also a cubic, like y equal to ax cube plus bx square plus cx plus d. Okay, if the a coefficient of x cube is greater than 0, the curve would be type 1, which we call that it starts or ends in 1 and 3rd quadrant. And another one is when the coefficient of x cube is less than 0, the curve will be type 2 curve, which will be in 3rd quadrant, sorry, which will be in 2nd quadrant and 4th quadrant. Okay, now we can go for third, which is 1 by x related curve, or we can also say asymptote related curve. Okay, 1 by x related curve, we can also write this in the form y equal to k by x minus a plus b. That means k x minus a to the power minus 1 plus b. Here we find the asymptote, no turning point, no point of inflection, but we get here from there the asymptotes. So asymptotes, x is equal to a line and y equal to b line. Just the difference is that it's asymptote, no coordinate. That's x equals to a line and y equals to b line. So when this is the type 1 curve, sorry, it will be asymptote. This will be the curve 1 type when coefficient of k, that means k is greater than 0, positive, and when k is negative, it would be like this, k is less than 0. Okay, then we can go for 1 by x square related curve. 1 by x square related curve. Okay, that is for number 1 by x square related curve. Okay, in 1 by x square related curve we got this can be also written as y equals to k by x minus a whole square plus b. So we can write it k x minus a to the power minus 2 plus b. Same here, asymptotes will be x equal to a line and y equal to b line. But when k is greater than 0, that means curve will be like this, first quadrant and second quadrant, and when k is less than 0, curve will be like this. Okay, this is x-axis, this is y-axis. Okay, this we call y equals to 0 line, and this we called x equal to 0 line. Remember, at y-axis x equals to 0, and at x-axis y equal to 0. Okay, then we go for root x related curve. Okay, root x related curve. From root x we can write it like this: o equals to k root x minus a plus b. That means k x minus a to the power half plus b. Okay, so from here we get the starting point, not turning point, not point of inflection. We get starting point. It means from where we will start the curve. Okay, so here the starting point is starting point, or we can write it sp, that will be a b. Similar rule, x minus a equals to 0, that means x equals to a and b. So here we can draw the curve x-axis, sorry, y-axis, then we go for x-axis. Okay, there are total 4 types of root x related curve. Basically one, let's start with this. It is root x. So what will be, this is minus root x, this is root minus x, and this is minus root minus x. You don't need to remember it very like, you don't need to panic about it that I just forgot. No problem, I will give you a shortcut. Just remember it, that transformation, it is root x related curve. Okay, so if for example f of x is equal to root x, and I have given you to draw minus f of x. Okay, so you know the transformation rule. Here the minus sign is outside, that means there will be change in y something. So we all know if there is minus sign in outside, so it will be reflection on x-axis. That means curve will be like this, reflection on x-axis. That means this is minus root x. Okay, easy. Then if we got f of minus x, that means minus is inside, that means root minus x, that means it will be reflection on y-axis. That means curve will be like this, root minus x, and another curve which is minus root minus x. So it's easy to remember. Then we go for exponential curve number 6, exponential curves. Okay, we can write it like this: o equals to k e to the power ax plus b. Remember, in exponential graph there is only one asymptote, which is y equals to something line, y equals to something. That means here the asymptote is y equal to b line, y equal to b line. What it is the asymptote. Okay, asymptote. So there are also 4 types of asymptote curve basically. So let's draw the y-axis, then x-axis. Now we can draw that this is e to the power x, this is x-axis and y-axis. Okay, then okay, let me write it like this way: y equal to e to the power x, then sorry, it will be like this way. Okay, okay, y equal to, this will be e to the power minus x, then here is another, this will be y equal to minus e to the power x, and the last one, this would be y equals to minus e to the power minus x. Okay, now we can go for ln x related curve. What? Ln x related curve. It was 6, so it is 7. Ln x related curve. What is basically ln? The log, when the base is e, we called it ln. Okay, okay, So ln x related curve and log something, it's same. So ln x related curve, we write it like this way. We are equal to k ln ax plus b plus c. Remember, in exponential there is only y equals to b something asymptote, and in ln x related curve or log x related curve there is only x equal to something asymptote. That means here the asymptote is what? X equals to minus b by a line. How? Just do this. Ax plus b equals to 0. That means if we subject the a, minus b by a. Okay. So there are also 4 types of ln x related curve. So let's draw it. The y-axis, the x-axis. Number 1, this is called y equals to ln x. Here point is 1. Then this is y equal to ln minus x. Then sorry for the drawing, however this is y equals to minus ln x curve, and the last one is this is y equals to minus ln minus x curve. Okay, so next is our trigonometric curve. Y equals to sin x. Okay, we all know the shape of y equals to sin x. It would be like this. Okay, here it would be 180 degree, it would be 360 degree, it is 90 degree, and this is 270 degree. The maximum point is 1, the minimum point is minus 1. Now from this we can also draw y equal to cosec x, means inverse, sorry, not inverse, reciprocal. That means 1 by sin x. So it's also easy, just remember it, that the cutting point on x-axis will be the asymptote, means the y equals to sin x curve cuts at 180 degree and 360 degree. So for example, our range is x is 360 degree to 0 degree. Okay, so between 0 to 360, the curve y equals to sin x cuts the x-axis twice, at 180 and at 360. That means there will be two asymptote at 180 and at 360. Okay, easy way to draw it, that's something like this. 1 by sin x will be just opposite or reflection, something like this. So a curve will be like this way, and here it will be like this way. So remember it in shortcut way. So this will be 1 and this would be minus 1. Okay, then we go for y equals to cos x. We all know the shape of the cos x is something like this. So it would be 1, this is minus 1, this is 180 degree, 180, this is 360, and this is 90. Okay, we all know it. Then from this we can got y equals to sec x, means 1 by cos x. Okay, how to draw the sec x? Similar rule like y equals to cosec x. So it's something like this, x axis, y axis. Here the y equals to cos x curve cuts the x axis at 90 and 270. Here another point 270. That means there will be asymptote at 90. For example, this is 90, and at 270 there is 270. Okay, so a curve will be like this. There would be something like this. So from here it would be like this. Then we got like this way, just reflection, something reflection, remember it. So then that would be like this way, and last one here is one that is like this way. Okay, so like this way, it is the 360. Okay, this is 1, this is minus 1, and it is 180 degree. Then we go for y equals to tan x. Okay, tan x, for example, we are drawing for 360, 0 to 360 degree, so it would be like this way. Here this part will be erased as it is not in our range. Okay, then there will be a asymptote at 90. Then another asymptote at 270, and this would be 180. And this will be 360. Okay, now let's try to draw y equals to cot x, means 1 by tan x. Similar rule, just draw the axes, x-axis and y-axis. It's cut at 0, then 180, then 360, then there will be 3 asymptote at 0. One asymptote is 0, okay, another asymptote is 180, okay, another asymptote is 360, okay. Then the asymptotes now will be the cutting point. That means, just remember it, that the asymptote will be the cutting point on reciprocal curve, and the cutting point will be the asymptote for the reciprocal curve. Okay, so now 90 in y equals to tan x, 90 is the asymptote. That means now 90 will be the cutting point for the this curve, and it would be like this way. In exam you should, before exam you must practice it, so that it would be easy to guess the shape. So this will be 90, this would be 180, this would be 270, and this is 360. Okay, now we can draw other related curves, but after we know modulus related curves. Okay, now we are going for modulus related curve, which is 9 number. Now modulus related curves. Okay, first of all we got f of x modulus of whole. That means it's basically, for example, y equals to f of x. Now y whole modulus, that means f of x whole modulus, that means it is basically, this is modulus of y. Okay, y is always positive. You know that inside the modulus it must be, modulus means that you will make any negative value positive or any positive value which will remain positive. That means y is always positive. So how you can draw the modulus curve from the f of x curve? Okay, erase the bottom part of the curve of f of x and draw it above. If there is any part of asymptote, that should also be drawn scale. Okay, no problem, I will draw here. Some examples are there. Now we got another modulus curve, which is f of modulus of x. This is modulus of x. X takes all values as positive. Sketch f of x, erase left hand side of f of x along the y-axis, draw right hand side of f of x on left hand side. Now let's do, we are supposed to draw both f of x whole modulus and f of modulus of x of this curve. This is the most difficult graph you can get in exam. If you draw it once, it will be helpful for you. So now let's draw the f of x whole modulus or related curve. Now we will draw f of whole modulus x. So what's the rule? Just again read, erase the bottom part of the curve, erase the bottom part of the curve of f of x and draw it above. If there is any part of asymptote, that should also be drawn scale. Okay, so what is the bottom part? Here the bottom part is this. So let's erase it. That means our asymptote will be asymptote x equals to 2 line. Okay, x equal to 2 line. This above part will be this. Okay, now the bottom part will be erased. That means you will erase this part and draw it above. Okay, so again read the rule, erase the bottom part of the curve of f of x and draw it above. If there is any part of the asymptote, that should also be drawn. Okay, Now we go for f of modulus of x. Okay, how to draw it? Let's erase the left hand side of f of x along y-axis. That means we will erase the left hand side of the curve, draw right hand side of f of x on left hand side. That means we have to first erase the left hand side, then we have to reflect the right hand side again on left hand side. Okay, that means we will erase this part. This is on the left hand side of the y-axis. We will erase which part? We will erase this part of the graph. That means first of all, let's give all the things same. That means asymptote will be here, x equals to 2. Okay, the curve will be here. Now this is on right side, this is also on right side, but this is on left side. Now what we have to do? We have to reflect this whole scenario. That means let me know you, this whole thing reflect on y-axis. So let's do it. First of all, you have to reflect this part. Okay, so there is the part. Now reflect it on this part. Okay, then x equals to 2, that means it will also be reflected. We will get an asymptote which is x equals to minus 2. X equals to minus 2. Then this part of the graph will also be reflected like this. Okay, so this is f of modulus of x curve. Then another example, we go for f of x. This is the f of x. So what will be the f of x whole modulus? Easy. First of all, we have to erase the bottom part. That means we have to erase this part. Okay, we will erase this part and draw the curve like this way. This is 2, this is minus 2, and the curve would be like this way. This is the 3. Okay, now f of modulus of x. F of modulus of f, that means we have to erase the left hand side. That means we have to erase this part. Okay, we'll erase it. Now draw the right hand side first, minus 3, 2, and again reflect this on the left hand side. It will be a similar type, minus 2. Okay, this is f of modulus of x. Now we are going for linear modulus. What? Linear modulus. 10 number. Linear modulus. Y is equal to k x minus a plus b. Here the turning point is a and b. So linear modulus curve are of two types, something like this. This, when the k is greater than 0, and f of modulus of x will be like this. Sorry for the drawing. This will be straight when k is less than 0. Okay, then we go for reflections. That means f of x will be changed minus f of x. That means it will be reflection on x-axis. Then f of x would be transferred to f of minus x. That means it would be reflection on y-axis. This is x. Okay, then we go for types of function. Types of function. There are basically three types of function. There are basically two types of function. Number one, one-to-one function. Number two, many-to-one function. But one-to-many is not a function. Types of function. Number one, one-to-one function. For one value of x, there will be one value of y. So how can you know that it is one-to-one function? Draw a line parallel to the x-axis in your sketch. If they intersect the curve only one time, the function is one-to-one. Then second, many-to-one function. For two or more values of x, there will be only one value of y. Draw a line parallel to the x-axis in your sketch. If the line intersects more than once, the function is many-to-one. And last, one-to-many. Basically, it is not a function. How can you know that it is a function or not a function, or it is one-to-many? Draw a line parallel to y-axis. If it intersects more than once, it is a one to many. It means, for example, this is a given curve, okay, and you want to know, is it one to one or many to one or one to many? Okay, let's draw a parallel line, draw a line parallel to y-axis. Okay, parallel to y-axis. You can see that this parallel lines parallel to y-axis cuts the curve twice. That means if it intersects more than once, it is a one to many, and we know one to many is not a function. Hence, for example, this has y equals to f of x. We can say f of x is not a function. Okay. Then we go for proper and improper. Lots of confusion. So proper and improper. Proper and improper. So we can say that more power in denominator make a fraction proper. What? More power in denominator make a fraction proper, and less or equal power in denominator with numerator makes a fraction improper. Okay, so some examples are, number one, let's say x divided by x square plus 4. Is it proper or improper? It is proper. Why? Because the numerator power is less than the denominator power. In denominator there is x square, and in numerator there is x to the power 1. So it is a proper. So then second, x square divided by x square plus 4. It is improper. So as it is improper, why it is improper? Because in denominator there is x square and in numerator there is x square. So the powers are equal. So it is improper. Number 3, x cube divided by x square plus 4. It is also improper. Why? Because the power of numerator is greater than denominator. We can say less power in denominator with numerator. That means the power of numerator is greater than the denominator. So it is improper. Then we go for sketching inverse trigonometric curves. Sketching inverse trigonometric curves. Okay, so first of all we got y equals to sin x. Okay, for inverse the function must be what? 1 to 1. So y equals to sin x, our range would be minus pi by 2 to pi by 2. So let's draw it. The curve would be like this. Okay, it is pi by 2, this is minus pi by 2, this is 1, and this is minus 1. Now let's draw y is equal to arc sin x. What does it mean? It means sin inverse x. The range would be what? Minus 1 to 1. Okay, how can you draw it? How to draw the inverse function? It's easy way to remember that you have to draw a line parallel to y equals to x line. So let's remember it is easy way to draw. You must have to practice it, then it will be in your graph. So this is minus pi by 2, this is 1, and this is, sorry, there is something, it would be not like this way, it will be this, yes, and it would be minus 1, and this is 1. Okay, then number 2, we got y equals to cos x. Range would be pi. Okay, so it would be like this way. this is the pi, this is -1, this is 1. Then let's draw y equals to arc cos x. It means cos inverse x. So the range would be -1 to 1. The curve would be like this. This is 1, this is -1, this is pi, and this point is the pi by 2. That means this point is the pi by 2. Okay, then 3, y equals to tan x minus pi by 2 to pi by 2. There will be two asymptote at pi by 2 and minus pi by 2. Curve would be like this. Okay, so now let's draw y equal to arc tan x. Arc tan x curve would be x equal to pi by 2 and x equal to minus pi by 2. Asymptote will be y equals to pi by 2. It will just reverse. X will be y, y will be x. Similar coordinates will also reverse. For example, there is a coordinate for this curve. Let's say there is a coordinate AB. For inverse function, that means for this curve, the coordinates will be BA. That means it will just inverse. X coordinate will be y, y coordinate will be x. So similarly, that x equals to x asymptote will be y asymptote. That means x equal to pi by 2 and x equal to minus pi by 2 will become y equal to pi by 2 asymptote and y equal to minus pi by 2 asymptote. The shape of the curve would be like this. Okay, then go for 4 number, which is y equal to cosec x. That means 1 by sin x. The range would be minus pi by 2 to pi by 2. So let's draw it. This, and it will be this. So let's draw it. The y equals to, this point is the pi by 2 and this point is the minus pi by 2. Okay, y equals to arc cosec x. Range would be 1 to -1. Similarly, so it would be like this way. Okay, this point is the 1, as it is 1 and it is -1, and this will be 1, this would be -1. Then it would be pi by 2 and it is minus pi by 2. Just it will reverse. Y coordinate, x coordinate will reverse. Then 5, y equals to sec x equals to 1 by cos x. Range would be 0 to pi. X is not equals to pi by 2. That means there is a asymptote. So let's draw it here, then there. Okay, this is 1, this is -1, this is pi, and it is pi by 2. Not equal to pi by 2 means there is an asymptote. So let's draw y equals to arc sec x. So the x equal to pi by 2 asymptote line will be y equals to pi by 2, right? Okay, so let's draw first asymptote y equals to pi by 2. Y equals to pi by 2 line. Then the shape of the curve would be this way and this way. This is pi, this is 1, and this is, let's draw it again, and this is -1. Then 6, the last one, y is equal to cot x 0 to pi. The shape of curve will be like this. You all know this is the pi and this point is the pi by 2. Let's draw y equals to arc cot x. What will be our cortex? There will be y equals to pi line asymptote, and shape of the curve will be this. This point is the pi by 2 is cutting point, x-axis, y-axis. Okay, now take some notes. That means sine inverse sine x is equal to x. X equal to arc sine and sine x. That means sine inverse, we can call it arc sine. Similar things, sine inverse sine x equals to x, cos inverse cos x equals to x. Then it is the most important part. Just remember, everything minus inside will be minus, but without these two is the exception. That means cos 1 by cos x and cos x. Sine minus x, that means minus sine x. Cos minus x means cos x. Tan minus x means minus tan x. Cosec minus x means minus cosec x. Sec minus x means sec x. This two is the exceptional, and cot minus x means minus cot x. Then a table comes. I hope you should and you must memorize it and remember, it will help you a lot. So sine 0 in degree 30, 45, 60, 90, and in radian 30, that means pi by 6, 45 means pi by 4, 60 means pi by 3, and 90 means pi by 2. So sine 0 means 0, sine 30 means half, sine 45 means 1 by root 2, it means root 2 by 2, sine 60 means root 3 by 2, and sine 90 means 1. In cos it is reverse, that means from 1 to write this reverse 1. Cos 30 means root 3 by 2, cos 45 means root 2 by 2, cos 60 means half, and cos 90 means 0. Tan 0 means 0, tan 30 means 1 by root 3, it means root 3 by 3. Tan 45 means 1, tan 60 means root 3, and tan 90 means infinite. Okay, infinity. Now trigonometric identities. Number 1, sec theta is equal to 1 by cos theta. Number 2, cosec theta is equal to 1 by sin theta. Number 3, cot theta is equal to 1 by tan theta, means 1 by cos theta by sin theta. Okay. Then number 4 will be tan theta. Tan theta means sin theta by cos theta. Then number 5, sin squared theta plus cos squared theta is equal to 1. 6, sec squared theta minus tan squared theta is equal to 1. Then 7, cosec squared theta minus cot squared theta is equal to 1. Number 8, sin A plus minus B, that means it would be sin A cos B plus minus cos A sin B. Then cos A plus minus B, it would be cos A cos B minus plus, sign will be opposite, minus plus sin A sin B. Then tan A plus minus B, it would be tan A plus minus tan B. Here the sign will be same, but there the sign would be reverse, tan A tan B. Now it's time for double angle formula. Double angle formula. Okay, in double angle formula, first of all you got sine of 2a, that means 2 sin A cos A. Then number 2, cos of 2a, it means cos square A minus sin square A. From this you can also write more 2, that is 2 cos square A minus 1, and another one is 1 minus 2 sin square A. Just if you write sine square a is equal to 1 minus cos square a, then you simplify and you will get this. If you replace cos square a is equal to 1 minus sine square, then if you simplify you would get this. Okay, then 3 tan of 2a, 2 tan a 1 minus tan square a. Okay, then finding exact value by changing ratio and selecting quadrant. Okay, for this, first of all, you have to know that note this sine 180 minus theta, that means sine theta, sine 180 plus theta, that means minus sine theta. Why? Just remember the quadrant. Sine 180 plus alpha, that means 180 there is 180 and plus, that means it would be in third quadrant, right? In third quadrant sine is negative. Okay, so sine 180 plus alpha, that means minus sine alpha, cos 180 minus alpha, minus cos alpha. Why? Because cos 180 and minus alpha, that means it will be in second quadrant, and in second quadrant cos is negative, that's why. And this 2 is one of the most important. Sine theta we can write is cos 90 minus theta, and cos theta sine 90 minus theta. Here it comes that in first quadrants all positive, and these are called acute angles. In second quadrant these are called sine positive and obtuse angle. In third quadrant tan positive and others all are negative and reflex. In fourth quadrant cos is positive and reflex angle. So let's take example 1 of finding exact value by changing ratio and selecting quadrant. Number 1, tan A is equal to 7 by 24, let's say, and A is reflex. Okay, A is reflex. Now let's draw a triangle. Okay, this is the A, then tan means opposite by adjacent, 7 by 24, and this will be 24 square plus 7 square, that means 25. Now tan A is equal to 7 by 24 and A is reflex. First of all, there are two quadrants that can be reflex. That is third, one is third and another one is fourth. Now see, tan A is positive, that means tan is positive, that means the reflex angle A exists in the third quadrant. Okay, okay. Now let's say we have to find out sine A. Okay, now tell me, in third quadrant sine is negative, so there would be must be negative. Then sine means oppo by hypo, that means 7 by 25. Then cos A, in third quadrant cos A also, that means A also negative, that means it will be also negative, and adjacent by hypo. It's easy. Another example, example number 2, that is, for example, sine B is equal to 5 by 13, and I told you B is obtuse. B is obtuse. First of all, obtuse is in second quadrant and it is positive. Yes, positive. Now let's draw a triangle. It is B, oppo by hypo, and this would be 12. Now what would be tan B? Tan B, that means in second quadrant tan is negative, that means that would be negative sign. Then tan B means 5 by 12. Then comes to cos B. Cos B in second quadrant cos also negative, that means there will be a negative sign, and 12 by 13. Okay, now for me find sine A plus B. Okay, calculate the value of sine A plus B using these two examples. Okay, sine A plus B means sine A cos B plus cos A sine B. We got all the values from here, sine A, cos B, all the things. Let's put it here. Minus 7 by 25 multiply by cos B is minus 12 by 13 plus cos A is minus 24 by 25 multiply by sine B is 5 by 13. The value would be minus 36 divided by 3 to 5. This is a full example. Okay, a good one, good example. I think after this there should be no problem on finding exact value by changing ratio, obtuse, reflex, anything you can answer it. Okay, now let's go for another theory, which is if any line makes an angle theta with x-axis after clockwise rotation, then tan theta would be equal to gradient of the line. Let's say y is equal to 2x plus 5 is a line. Let's draw it. Okay, it is something like this, and this point is minus 2.5. okay, this is x-axis and this is y-axis. Let's say this angle is theta. Okay, and for example we are considering 2. Okay, we are considering a point that is x equals to 2. At x equals to 2, we can put it here, 2 into 2 plus 5, that means 9. That means y coordinate would be 9. So the tan theta would be what? Tan theta would be oppo by adjacent, that means 9 by here full length of this 2.5 plus 2. 0.5 plus 2, that means 9 by what? 4.5. 9 by 4.5 means 2. See, tan theta is equal to 2 and the gradient of the curve is 2. That means it is equal. Okay, after that we are going for application of R form. Application of R form. Let's say a sine x plus minus b cos x is equal to r sine x plus minus alpha. Then b, a cos x plus minus b sine x is equal to r cos x minus plus alpha. C, r we can calculate a square plus b square, and d, tan alpha is equal to always b by a. That means alpha is equal to tan inverse b by a. In this application of R form, students face problem. As it is revision video, I cannot give you more details, but if you want before the P3 exam on 29th May, you can comment, as it is my first video, you can comment and I will help and try to make you clear with some question paper examples. Okay, in October 22 there is a good math on it, you can check it. Okay, so I will now I will not do it because it's a revision video, so I don't have enough time. So let's go forward. If you need any further queries about this, you can DM me or comment on it. Then logarithm and non-linear data. Now logarithm and non-linear data. Okay, number one, y is equal to a x to the power n. So how you can make this format into logarithm format? So take log on both sides. Log of y base 10 is equal to log of 10 a x n. Log of y base 10, you can split it like log of a base 10 plus log of x to the power n base 10. So log of y base 10 is equal to, this n can be written as n log of 10 x plus log of a base 10. Now compare this with y is equal to mx plus c. Here the, let me 1 minute. Now here m is equal to n and c is equal to log a base 10. So let's draw a graph. For example, this is log of y base 10, this is log of x base 10, and a graph is this, and this point is the log of a base 10, and its gradient is equal to m. Then steps to show working. A good example of this math is P3 at Excel book, page number 111, example number 7. I'm talking about this math exactly. So these are the steps. Step to show: plot the data for log y against log x, draw the regression line considering 2 points, calculate the gradient for regression line, use y equals to a plus bx, your calculator to obtain values of ab, and here are the steps. It is for fx991ex, and other calculators have other functions, you can check. Now let's go for numerical method. In numerical method, to identify root, we have to check the change of sign, positive and negative, from f of x. For example, there is a graph, this is the root alpha, and there is a point a and there is a point b. So f of a is negative and f of b we got positive. That means as there is a change in sign and the curve is continuous, so our root or alpha lies in within the interval atho. Within the interval this. Okay, so then we got this curve, and look here, no changing sign. Let's say f of a is positive and f of b also positive. That means this theory doesn't haven't come yet, but these are important, these two. So then we would differentiate, and if inverse a is negative and inverse b is positive, that means the root lies on the turning point. At turning point is x is equal to alpha, and so x equals to alpha is a root. Then the last one, for example, this is a curve of 10x and there is an asymptote pi by 2. There is a point a and there is a point b, and if we find f of a is positive and f of b negative, but this is not the root. Why? As there is a change in sign, but there is no root in the interval. Why? Because the curve is not continuous within the interval, or because there is an asymptote atho in x equal to pi by 2, or the curve is not continuous within the interval. Okay, then next point, to show that x coordinate of a turning point lies in an interval, we check change in sign from f inverse x equals to 0. Okay, to show that x coordinate of an intersection point of two graph is atho, it means, for example, we got f of x is equal to x square minus 2 and g of x is equal to e to the power x minus 3, for example. So how can you know that the intersection point? Let's x square minus 2 is equal to e to the power x minus 3, then x square minus 2 minus e to the power x plus 3 is equal to 0. It means x square minus e to the power x plus 1 is equal to 0. Then make this as another different function for us. H of x is equal to x square minus e to the power x plus 1. Then put the values, for example, a that is positive, then b that is negative. Then you can say as there is a change in sign and the curve is continuous, so our root lies within the interval, to intersect within the interval. Okay, after this we now we can go for differentiation part. Differentiation part. Okay, in differentiation, let's say ddx dot, that means in everything we would put ddx. So ddx of e to the power x is equal to e to the power x, that means ddx, I just wrote it ddx. Then b, e to the power kx means e to the power kx into, then differentiate this part kx, that means k, that means answer to be k e to the power kx. C part would be a to the power x. That means a to the power x into ln a. This part also can be done is like that's why e power, that means it would be 1. That's why it's done like this way. So a to the power x is equal to a to the power x ln a. Then d a to the power kx means k a to the power kx ln a. Then e ln x is equal to 1 by x if ln kx is equal to 1 by kx into, differentiate this part again, k, that means k cut 1 by x would be the answer. G log of x base 10, take it to ln base, ln ddx of, okay, let's do it again. Here would be ddx. First of all, take it into ln base, ln x ln 10, then differentiate it 1 by ln 10 into 1 by x, that means differentiate it, sorry, ddx of eto, then 1 by x ln 10. So I have differentiated it already, so this would be 1 by ln 10 into 1 by x. Okay, as 1 by ln 10 is a constant value and ln x is our main differentiate part, h 10x is equal to sec square x, I cot x is equal to minus cosec square x, j sec x is equal to sec x and tan x, and last one cosec x is equal to minus cosec x cot x. So here all the differentiation. Now we can go for the differentiation of inverse trigonometric function. Okay, what is this? A part will be proof that ddx of arc sin x is equal to 1 by root 1 minus x square. So let's say y is equal to arc sin x, that means y equals to sine inverse x, that means x is equal to sine y. So let's differentiate it, dx by dy is equal to cos y, that means dy by dx is equal to 1 by cos y. Now we can use the identity sine square y plus cos square y is equal to 1. So we know the sine y, that means it would be x square plus cos square y is equal to 1. So if we subject the cos y, it would be root 1 minus x square. So just substitute it, root 1 minus x square. It's proved. Similarly, you can show another b, y is equal to proof that ddx of arc cos x is equal to minus 1 by root 1 minus x square. It's also in similar way, do it in similar way, that is y is equal to arc cos x, that means x is equal to cos y, dx by dy is equal to minus sin y, that means dy by dx is equal to minus 1 by sin y. Now you know the cos y, that means use the sine square y plus cos square y identity is equal to 1. So now subject the sine y, if we subject the sine, it will be root 1 minus cos y is x, that means cos square y is x square. So substitute it, minus 1 by root 1 minus x square, proved. Then C, prove that ddx of arc tan x is equal to 1 by 1 plus x square. Okay, y equal to arc tan x, that means x equals to tan y, so dx by dy is equal to sec square y, so dy by dx will be equal to 1 by sec square. Now use the identity sec square y minus tan square y is equal to 1. So subject the sec square y, we would get 1 plus tan square y, that means, sorry, tan square y not theta, so 1 plus tan y means x, means x square, that means we get 1 by 1 plus x square. Proved. Then second d part, proof ddx of arc cot x is equal to minus 1 by 1 plus x square. Okay, then we get y is equal to arc cot x, that means x is equal to cot y, that means dx by dy would be minus cosec square y, so dy by dx would be minus 1 by cosec square y. Use the formula cosec square y minus cot square y, so identity not formula equals to 1, so we can subject the cosec square y, that means cosec square y is equal to 1 plus cot square y, cot y is x, so cot square y x squared, that means minus 1 by 1 plus x squared. Proved. Then comes E part. E is proof that ddx of arc sec x is equal to 1 by x root x square minus 1. So y equal to arc sec x, x equal to sec y. If we differentiate it, dx by dy, we get sec y tan y, that means dy by dx would be 1 by sec y and tan y. So use the identity sec square y minus tan square y is equal to 1. So we got sec y, that means x, that sec square y is x square minus tan square y is equal to 1. So tan y would be root x square minus 1, then substitute it 1 by sec y, that means x, multiplied by tan y root x square minus 1, that means 1 by x root x square minus 1. Proved. And there is the last part, which is proof that if proof that ddx of arc cosec x is equal to minus 1 by x root x square minus 1. So y is equal to arc cosec x, that means x is equal to cosec y, so dx by dy, that means minus cosec y cot y, dy by dx would be minus 1 by cosec y cot y. Use the identity cos square y minus tan square y, sorry, cosec square y minus cot square y is equal to 1. That means we know the cosec y, that means x square minus cot square y is equal to 1. That means cot y is equal to root x square minus 1. So we can substitute it minus 1 x root x square minus 1. Proved. Here are all the differentiation. Now it's time for the integration. So integration applies for both P3 and P4. Okay, you can remember it in PESC cube, that means P for polynomial, E for exponential, then here comes SC cube, means sin x cos x, or sec square cosec square, and another one is secant cosec cot. Okay, so let's write it. A, all integration, that means integration of dx. Okay, so I write it at first. So now let's do it. A to the power x, sorry, x to the power n is equal to x n plus 1 n plus 1 plus c. Then b part 1 by x equals to ln modulus of x plus c. These two are polynomial p. Then go for c part. In c, e to the power x, integration of e to the power x, that means e to the power x plus c. D, a to the power x, it means a to the power x divided by ln a. These two are exponential. Then here come sc cube, that means e part would be sin x integration minus cos x. Remember, differentiation of sin x means only cos x, but integration of sin x means minus cos x. Okay, then if cos x is equal to sin x, here also remember, differentiation of cos x is minus sin x, but integration of cos x is means sin x. G sec square x is equal to tan x. H cosec square x is equal to minus cot x. I sec x tan x is equal to sec x. J cosec x cot x is equal to minus cosec x. And another form is that rearrange given trigonometric equation to apply formula for integration, and integration using identities also. You can there are some identities, for example, integration using identities, integration using identities. Okay, there are some identities. They are number 1, sin square x equal to half 1 minus cos 2x. Where it comes from? It comes from simple cos 2x equals to cos square x minus sin square x. Then cos 2x is equal to 1 minus 2 sin square x. That means if you subject the sin square x, it would be like this. Then number 2, cos square x is equal to half 1 plus cos 2x. Shortcut to remember, in sin square x there is 1 minus, and in cos square x there is 1 plus. Okay, then 3 number, tan square x is equal to sec square x minus 1. It means sec square x minus tan square x is equal to 1. Similar, so iv cot square x is equal to cosec square x minus 1. Then come for this sin x cos x is equal to half sin 2x. Then 2 sin a cos b is equal to half sin a plus b plus sin a minus b. Then 3 cos a sin b, cos a sin b, it will be half, just the difference will be, there will be minus sin a plus b minus sin a minus b. Then 4 number would be cos a cos b, it would be half cos a plus b plus cos a minus b. Then here comes the last one, sine A sine B is equal to minus half cos A plus B minus cos A minus B. So that's all you can, and in P3 you will mostly get that integration using substitution. That's the easy part. And thanks for watching. This is the full P3 syllabus. You can see the video again and again. It would help you. And if you need any further help or any paper solving or any topic, you can just comment on this video. I will help to provide it before 29 May. Thank you.